Hey, it's Mr. Estrada here, and in this video, we are going to tackle this learning target, which says I can determine whether the orthocenter of a triangle will be inside, outside, or on the triangle. So you probably have no idea what orthocenter means, and you won't for the next couple of minutes, because I want to start by defining an altitude. An altitude of a triangle is a segment from any vertex perpendicular to the line containing the opposite side. So if you look at the triangle here to our left, the altitude connects the vertex and it's perpendicular to the opposite side. And a triangle has three altitudes. One of them is there, but here is another altitude. I'll go ahead and draw it now. Use this color. So this is also an altitude, this black line I just drew, because it connects a vertex and it's perpendicular to the opposite side. And here is another altitude. It connects a vertex and it is perpendicular to the opposite side. So those are the two key things. It's got to be perpendicular to the opposite side and connect to a vertex. So there are three altitudes here. Where the three altitudes intersect is called the orthocenter. And let me get that for you here. So the orthocenter, we'll talk more about the rest of this stuff here in a second. But for now, I need you to know that the orthocenter is the place where the altitudes of a triangle intersect. So this is what I need you to know right now. Orthocenter is the place where the altitudes of a triangle intersect. You can also call the orthocenter the point of concurrence. And concurrence is just the concept of three or more lines intersecting in a single common point or having a single point of intersection. Let's go back to our previous slide. So our orthocenter, take that volume off. Our orthocenter is right over here. That's our orthocenter. And it's where the altitudes intersect, and it's also called the point of concurrence. Or that's where it is said that that is where the lines are concurrent. As you could see, the altitudes of our acute triangle here intersect inside the triangle. So the orthocenter of an acute triangle is inside the triangle. And let's take a look at this animation I created here. This is also an acute triangle. As you can see, all the angles are less than 90 degrees. And the orthocenter, of course my computer's performing slow, the orthocenter is inside the triangle. And that will always be the case. As long as the triangle is acute, the orthocenter will be inside the triangle. Let's see if I can move this around a little bit. So point P is our orthocenter here. Now, what happens if our triangle is obtuse? See what happened there? We have an obtuse triangle because one of the angles is more than 90, and our orthocenter is now outside of the triangle. Will that always happen for all obtuse triangles? Well, let's see. Let's try to make more obtuse triangles. And it appears that it will be true. See here, it's exactly on the triangle, and we're going to talk a little bit more about that later, but this is not an obtuse. But when it is obtuse, you could see that the orthocenter is outside the triangle. Why is that? It goes back to the altitudes. If you recall, an altitude is a segment from any vertex to the line, an altitude of a triangle is a segment from any vertex perpendicular to the line containing the opposite side. So here's what happens. The altitude of this obtuse triangle is actually outside of the triangle. There's no way you could draw this altitude and have it be inside the triangle, because if it's inside the triangle, then it's not going to be perpendicular to the opposite side. So definition of an altitude says it has to be perpendicular to the opposite side. So if we extend this side, it will be perpendicular outside the triangle. So that's why for an obtuse triangle, your orthocenter is going to be outside, because one of the altitudes is outside of the triangle. In fact, I think all of the altitudes are, except for this one here. So it looks like 2 of the altitudes will be outside the triangle. Let's see for ourselves. Try to draw more altitudes. We know this one. This altitude here. Let's go ahead and draw it. It's not really perpendicular to the opposite side, right? It's got to be perpendicular to the opposite side. Okay, we'll say that's perpendicular. And then this altitude here will be outside of the triangle, because you gotta see this line here, you gotta extend it so that it'll be perpendicular here. So yes, you're gonna have 2 of the altitudes outside of the triangle, and that's why your orthocenter will be outside. Alright, so we already went over concurrence. Concurrence just means it's the concept of 3 or more lines intersecting in a single common point, having a single point of intersection. The orthocenter is where the altitudes of a triangle intersect. In an acute triangle, the orthocenter is inside, and in an obtuse, the orthocenter is outside. Okay, let's summarize this a little bit. If the triangle is obtuse, then the orthocenter is outside the triangle. If the triangle is acute, then the orthocenter is inside the triangle. What about if it's a right triangle? We didn't talk about that, so let's talk about that now. Let's make a right triangle. So let's see if I can make K 90 degrees. There it is. So what happens when you have a right triangle, as is the case here? You're going to see that the orthocenter is on the triangle, and that's because 2 of the altitudes are on the triangle. So for a 90-degree for a right triangle with a 90-degree angle, the orthocenter is on the triangle. It's on the triangle. So if the triangle is a right triangle, then the orthocenter is on the triangle. Okay, that concludes our video for today. I hope this helps. Take care.